Greetings of the day, everybody, and welcome back. In this particular playlist, we are trying to solve the numerical problems related to the concept of circular motion. All of these questions have been obtained from the Cambridge publishers. The name of the author is K.A. Sokos, and this is the 7th edition of the entire series. In this specific question, we are now trying to solve a question related to the centripetal acceleration. The formula for centripetal acceleration is given by AC is equal to V squared upon R, where V is the linear speed or the linear velocity. There is yet another variation of the same formula, which is omega square R, with omega being the angular speed and R is the radius of the circular path. Now, in this specific question, we have been given the value of the angular speed and the radius. Therefore, we shall be putting to use this specific formula in determining the centripetal acceleration. So, AC is now equal to 2.1 whole squared into the radius has been given to us as 2.0. This will now provide us with a 4.41 into 2.0. The final answer would be 8.82. This is the centripetal acceleration meter per second square. Now, whenever we solve these numerical problems, we need to make sure that we report the final result to the appropriate number of significant figures. There has been multiplication involved here, so we shall be considering the number of significant figures and not the decimal places. So the centripetal acceleration is then 8.8 can be reported as 8.8 meter per second square. Now this will be the final answer to the A bit. Now when we look at the second bit, that is the B bit here, it has been provided to us that the radius of Earth is 6.4 in 10 power 6 meters. Again, the question is about calculating the centripetal acceleration. The formula continues to remain the same. AC is equal to V squared upon R. Now, since no other value has been provided, we pretty well know a person who is present at the equator will complete one full rotation in one day. So the time period for this particular person would be 24 hours. From this, and since the radius also has been provided, we are in a position to calculate the linear speed. Linear speed, we pretty well know it would be 2 pi r upon capital T. Here, the r would be the radius of Earth itself. Substituting the values, I will end up having 2 pi, the value of r is 6.4 into 10 to the power 6. All of this divided by the time period is 24 hours. So 24 hours, each hour has got 60 minutes and each minute has got 60 seconds. Therefore, the value of the linear speed, let's do a quick calculation here. That would be 2 into 3.14, all right, into 6.4 divided by 24 divided by 60. This further divided by 60 will give us a value of 4.65 into 10 to the power negative 4, and this will be multiplied further by 10 to the power 6. Remember, while we were substituting the values in the calculator, we did not consider 10 to the power 6. So this value will therefore be the velocity, the linear speed would therefore be 4.65 into 10 to the power 2, can be written as 465 meters per second. Now, if this is the linear speed, we already have the formula for centripetal acceleration. It is AC is equal to, again, V squared upon R. R here is again the radius of the Earth. So 465 square divided by 6.4 10 to the power 6. Let's quickly calculate this value here. I would have 465 squared divided by 6.4 comes out to be 33,785. 33,785 into 10 to the power negative 6. Expressing it in the scientific notation, I would have 1, 2, 3, 4, 5, and 6. So 0.03 meter per second square. That would be the centripetal acceleration as experienced by a person who is situated near the equator. Now, since I mentioned that we would like to express this in the form of a scientific notation, this would be 3.3 into 10 to the power negative 2 meter per second square to the appropriate number of significant figures as well. Now this is the response, or this is the answer to the second bit here. Moving on to the third bit here, a mass moves in a circle with a constant speed in a counterclockwise direction as shown in the figure. Determine the direction of the velocity change. They're not asking us to determine the velocity, they're asking us to determine the change in the velocity when the mass moves from A to B. So at the point A, am I allowed to say that the direction of velocity is going to be tangential, therefore vertically upwards? At the point B, again it is going to be tangential, therefore it will be horizontal and pointing to the left. Since we were supposed to determine the change in velocity, it is always the final velocity minus the initial velocity. This is the final velocity. The initial velocity is in the upward direction. Negative of the initial velocity would therefore be in the downward direction. All right, now if I try to apply the triangular law of addition, this is in fact minus u. The change in velocity will now therefore be represented by the third side of the triangle. That would complete the triangle going all the way from the tail of the first towards the head of the other. This will now therefore be the direction along with the magnitude. I mean, if at all we draw it to scale, it would come out much better. So this is the direction of the final, or rather the change in velocity. Hope you understood all of this. Kindly subscribe, like, and share. Goodbye.